Good. Good morning, everybody. This is the second day of PyCon tutorials, and especially the scientific plotting with matplotlib. My name is Mike Müller, and I will be your instructor for the next 3 hours, and we're going to look at matplotlib. Maybe a few words about me. I've been using Python since 1999, so it's quite a while. So I started out with Python version 1.52. It's been worked quite a while with it. And I've been training Python since 2004, and the Python Academy, where I'm now, it exists since 2006. So I spend most of my time actually in preparing and doing Python training in all sorts of things. And like a third or half of the people I train are scientists in one way or the other. So we have a special science course for scientists. And matplotlib is one of the things I teach. And I also teach tutorials, and I taught these tutorials at EuroSciPy already. So who of you considers themselves being a scientist or engineer or something like this? Okay, it's about half of it. So that's what I expected, because matplotlib appeals to scientists especially, and that's where it comes from. But it can be also useful for other purposes. Just a few questions about your Python experience. Who knows Python less than 1 year? Okay. Less than 2 years? Less than 5? Okay. And more than 5? See, so it's about that. Okay, it's like a nice mix. I gave a tutorial yesterday, was pretty much the same, though you have people that don't have a lot of experience and people might have quite a bit. The goal of the tutorial is I want to introduce you to the basics. So matplotlib, you can do a lot of with matplotlib, but I want to give you a solid foundation how things work, and from there you can go on and discover new things. As soon as you have this foundation, it will be much easier for you to look at this very nice website and look at the gallery and understand how things go on. So everybody of you should have a handout. I put them there. If you don't have one, I have some more here. Okay. Just one. So everybody, of course, the handout is pretty comprehensive, so everything we do is actually in the handout. So you should be able to follow along yourself with the handout. It should work. So we work with the handout, which gives you some things. Even if you somehow get lost, you should be able to read up on the handout. And we will do a few exercises. I think it's important, because as long as I explain everything so nice and clear, and if you do yourself, then small problems pop up, and then that's where you learn the most, if you do some exercises. Okay, so we look at the basics of matplotlib. Who of you also attended the IPython tutorial yesterday? Just a few people, yeah. So IPython and matplotlib very often work together, and that's also how we work here. So we use IPython to work together with matplotlib to do some interactive sessions. So hopefully everybody of you has installed all the software, all the prerequisites, and we're going to start. So matplotlib actually is the 2D plotting library in Python. Came up over the last years. I still remember 10 years ago I used something different, but the last few years pretty much everybody is doing matplotlib, and for good reason, because it's a very powerful library for 2D plots. So let's get started. So no matter what operating system I tried everything on Mac and Linux and Windows. It worked all over the place. So all the examples I had, they worked as long as I have everything installed as advertised on the website. And just go to a shell window and start IPython. And the way we do this, we say IPython minus pylab. So I use a traditional IPython. The people that took the IPython course yesterday, they introduced the notebook, which is a brand new thing. I haven't did it yet in the course. It just came out last year, and I tried it, and there might be still a few things that are pretty new. But we use the IPython on the command line, which is fine. There's also a version working with Qt. So if you say IPython minus pylab, then IPython, you see I have IPython 13 already, which is the one that has a notebook, but we still stay with this version. If you want to run with a notebook, then you have to give some special commands. Okay, that's what we do. We start IPython, and this should work for all of you. And now we have this nice IPython prompt. I make it a bit bigger so everybody can see. Everybody can see in the back of the room? Okay, so now we have this IPython. It's an enhanced Python shell that gives you some more things than you have with Python, and you're welcome to discover it, because you have things like if you do something like this, and I say dot and press tab, then I get a list of everything that's inside. So you have tab completion, as far as you can get on the console with tab completion, and a few other things. If you press a question mark and stuff like this, you get help, and things like this. And you can also just do something like this. You can just do normal shell commands, and it's smart enough to recognize what you want to do. There's also a way to force it to say there's a shell command. So it's doing those kind of things for you. But we want to use it with matplotlib, and let's go on with the handout. So we stick to the program. The easiest way to plot something is a plot command. So calling this with -pylab imports matplotlib already, and then you have this plot command here. And the easiest way is just you can plot something, and if you just supply a range of numbers, it takes those numbers and plots them. Wow, where is it? Okay, right here. So there are different backends for matplotlib. Here you have this window, and this usually works with tkinter, which is a default, which should be installed when you install Python have idle. But it also works with wxPython Qt or PySide. So actually, I had more luck to install PySide on a Mac than Qt. Qt didn't want it, but PySide was pretty nice. So PySide is supposed to be a drop-in replacement for PyQt. But that's just a backend question. Now we have this window, and this window, we have a few things you can do. So you have this down here, you have the zoom button. If you click this one to enable zoom, and then you draw a rectangle, you zoom in. You see now the scales are changing, and I can zoom in and can get finer. And then you have those buttons here. There's like in a browser back and forward button, so you can go back and get the last state and so on, back and forth. In this house here means home, so you can get the original state. This is panning, so here you can, it's kind of a not very beautiful widget, but it works. So from here you can change the shape. You see if I do something like this, it's changing the shape of the thing. And this is a TK version. If you use a Qt version, they even have a few more things. You can change the access title and stuff like this. So if you see this toolbar not down here but up there, then you have the Qt version probably, and there might be some more functionality. And if you close this, and then this one is a save button. Everything you do, you can save. And you can have many different formats. You can should save it as okay, it doesn't tell you here. You can save it as pixel, that's PNG and JPEG graphs, but you can also as SVG and PS. So, or EPS, so vector graphics. So, and typically the quality is pretty good, and those backends for saving things getting better over the years. So in the beginning, like SVG didn't work very well and just didn't take all the data or whatever. But nowadays it looks like everything is fine, so you can store the things as interactively. Okay, this is our first plot, but it's not much yet, and now we can do a few things. Now we work on this interactive thing, and this interactive thing is designed, it's actually already taken from MATLAB, that where it comes from. So it's designed to just with a very small effort to do something. So there's no import, as you can see. There's no dots, everything, you just can start working. We will see later on, in the later session, we see that if you want to write a bigger program, you don't want to do this. You want to import things and work with objects. That's something we do later. That's all there. But the API is very similar. So everything we learn now interactively, you can transfer one-to-one to this object thing. So that's nice. So, but this is nicer for demonstration. Now we set the X label. So I would like to set the X label. And I say something like measured values. And as soon as I press enter, then you look again. Maybe I just make this a bit smaller, then we can have them side by side. And put this here. You see, the minute I say measured, this measured appears down here. And I can do the same thing. So the arrow up gives you the history here. I say Y label, and this one is not measured but simulated, or what do I say, calculated, whatever. So just to say you can give your axis some labels. See, and now this moment I do this, right there it appears and it's there. And you can also set a title. So it's the same thing. Everything is functions. In matplotlib you will see there's not a lot of kind of attribute to set. It's more everything is a function, and you call this function title, and you just write something in there. Everybody got it to work? Good. So the measured versus calculated. Something like this. And you can type it in, and the minute I type it, see it comes, it's interactive. Most of things happen immediately when I just press enter. A few things they need you to redraw things. You can also set a grid. So there's a grid command, and this gives you a grid. See, now we have this grid in the background, and you're getting closer to something that you could even publish already, if this very plain line is what you want to show. Okay, and now we have done everything just with a few commands, so magically it found the graph to work with. But very often you need a reference, but we didn't save a reference for our plot. But you can get a reference to your plot to say my plot is get current axis. So get current axis is one of those, it's taken straight from MATLAB. And the axis, there's two things, like axis is a whole plot, and axes is a x and y. So it's very similar names. Now I have a reference to this. So if you type this, you can look at it, what it is. My plot. And you see matplotlib axis subplot. That's a subplot. This thing is called a subplot. Now I have a reference, and now I can do something with this reference. And this plot has lines inside. So this blue line is actually, you can access by saying my plot dot lines, and this is just a list of things, and you can just say okay 0. Yeah, so you say 0, and now you have your line, and this is a matplotlib line, a 2D line. So matplotlib is mainly 2D. There's a few 3D things, but we focus on 2D here. So we have this 2D things, and now you can work with this line. You have a reference with this blue line here, and you can do something with it. You can say line dot, and they have a bunch of those set ones. So if you do set underscore and press the tab, you get a long, long list of everything you can do with this line. Yeah? Oh yeah, sorry? Like this? Okay, sorry. So I have a long, long list, but the font is big enough in the back there? Can you read? Yeah, okay. So I have a long list of stuff you can do, and everything works with this thing. You have set, underscore, and then you have what you want to do. You see a lot of things you can do with this. You can set a lot of those properties here. Yeah, don't unplug me. You can do a lot of things here with a set thing. And everything is the same syntax. Set, underscore, and it's a long list of stuff. You can see it's like 20, 30, 40 things you can do. And one of the things you can do, you can set the marker. Yeah, the marker is this thing that's printed. There you have the data node, or data in general. And if I say marker little o, then nothing happens. See, that's usually there's supposed to be something happen. And if nothing happens, then you have to say draw, and now something happens. So most of the thing it's interactive immediately, but if it's not, don't worry, just call draw. A few things are not happening immediately. And now you see you have the marker. As we have this 9 points here, or 10 points from starting from 0 to 9, and now you see the marker. That's a way to change the properties. That's one way, using this the method. It's a method sitting here as attribute here at this object line. But you can also use functions. Sometimes it's nicer to use functions, so you don't have to go and call the method. You can use a function. A function is easier to use in a loop or something like this, because in a function you hand in the line object itself, and then as a keyboard argument what you want to do. And I would like to change the color to green. So if I do this, I use it now as a set property, and this returns none. And see, now this came up immediately and changed my line to green. So you might see it here, now it's green. And it's a second way to change a property. You can just use this one. And this can be handy, because if you have a list of objects, you can loop over it and just give it as a first argument to a function, for instance, in a loop, or something like this. And change all of them, if you like to. Which is also possible with an attribute, but it's more work, because you have to do get attribute and stuff like this, and it's much nicer to using a function. So that's another way, so you can change properties of the things. Okay, now we would like to do another plot, and first of all I want to get rid of my old plot, and there's a command called clear current figure. And if I do this, everything is gray, everything is gone, and you can start from scratch. That's only interesting for interactive sessions, but very often it's very nice to have some interactive session to test something without saving a file and opening again and stuff like this. So you can play around. It has a disadvantage sometimes, you might have some artifacts, because you did a lot of work and you saved a lot of bunch of variables, and now you've forgotten that you had an X and an A and a B somewhere, and now something strange happens. So that's always, if you do interactive sessions and something strange happens, close the whole thing, open it again, and then it's faster than compiling something. You don't even get a coffee, but it works again. Okay, so X is A range. So A range comes straight from NumPy. Who knows NumPy? Yeah. So NumPy is a numerical library for Python, and NumPy is used here, implicitly is imported, because all the scientists actually use NumPy. And there, NumPy does the thing called A range, is very similar to range, but instead of giving you a list, it gives you an array. So you could, in this case, you could also use a range, wouldn't be any difference. The only thing is A range, all the members of this array have the same type. A list you can stuff in anything while you want, any object. In the array, everything has to be an integer or float or whatever you would like, but it has to be the same. So we do an A range of 100, and we say linear also, just do it the same, is also A range of 100. So we have an X and a linear one, and we have a square. And the square, for this one I use a list comprehension just to do something different. Hopefully everybody knows what list comprehension is. So I just say, okay, I want to have a square of V for all V's in this A range. And A range, it's a bit different than the normal range, but with the A range you can specify a step which is not an integer but rather a float. So I can specify a step of 0.1 instead of specifying a step of an integer. So with a range you can specify a start, stop, a step, but with A range you can have the step be a float like this one. So we have our square numbers. And now we plot them. And now do it differently. Now we get a reference to our plot in the middle. We don't have to do the get current stuff. So we just say lines equals plot. And we just plot it. And now we use two plots. We have X, and we put our linear numbers in there, and use the X again for our square numbers. So this would be the XY, XY. So we use the same X for both of them. Square. And if everything is right, then this thing should show up, and you see now we have our linear one and the squared one. So just to have something, there. And now we can also add a legend. We say legend, and the legend you have to give it a list or a tuple, a list with strings, and those strings will be used for your lines, because those lines are in the list, so they have an order. The blue line is the first line, and the green line is the second line. And I can use the same order for my legend and say linear and square. Yeah. So, and it's using this, I just use a tuple here, and I do this. It puts the legend, you see, the legend now is up there. And that's not very nice, because the legend is right on top of my curves, but I have so much space here and there, and I didn't put it there for some reason. But you can, if you like to specify where you would like have things. So we just clean the whole thing again. And it's easy now because we have our command, this plot command. And now we modify our plot command a little bit. You can give optionally a string with some properties. So I would like to have this one green, and I would like to have the line dotted, and the marker a plus. So this is a very short notation, but you get used to it very quickly. There's longer ways to do it. So they have now a green line. This is the first one. A colon means dotted and a plus. No worry, we will look at the table with all those properties. And then we have a red line, which is dashed and has column as markers like a small circle. And if you do this, you see now you have your. You cannot see it's dashed. You have to zoom in to see that this is dotted, this is dashed, but you have all this markers here. And now we put our legend. So we put our legend, and I also would like to have a legend would have the reference. So every time you use a function, it returns itself a reference to itself. If you create something, it's like a constructor. It creates something, and you get a reference, and you can do something later on. And this takes the optional argument location, so you can specify where you want it, and you can give it coordinates where you want to put it, but also it has the notion of these 4 corners. So I say upper left. So I would like to have it in the upper left. So and if I, no, should be okay. If I do this one, now see now it appears in upper left, and you can see now it shows you the dotted and the dashed line with your markers. Though we have your legend up in the corner. So of course now we can also add labels, and then you have a nice graph. Good. I think it's easy enough. So do a short exercise. Should just take a few minutes. On page 7, I have an exercise, and try for yourself. Play around a little bit, and I will be here. If you ask me questions, we can do things. Let's continue. A few problems to set things up, but let's go on. So let's look a little bit more at properties. You looked at this already, so we made this nice and colorful, and just a few things about properties. So you have different ways of setting properties here, and just look at them quickly. So we have a big table of properties here, and just make it bigger. And you see here, you can set a lot of things. And you have actually 3 ways setting a property. We used all 3 of them. You can specify them at construction time, just like this. You can use the set property function, and you can use the set underscore something method to set properties. Let's look what we have. There's a bunch of properties around. A very nice one is alpha, so you can actually set the transparency of an object. So if it's 0, you don't see it. If it's 1, it's opaque. So it's 0. And like if you do it 50, you get this kind of pastel-like colors you can look through, which can be very useful. If you plot something on top of each other, you can see what's underneath. That kind of works. So that's pretty good. And then we have a few of other things, colors and labels and line styles and line widths and markers and all kind of things you can set here for these lines, for instance. And then you have this line styles. We used a few of them, and there's a bunch of them, and all of them have this nice symbols, which is something easy to use. And you see you have a lot of different line styles. So sometimes you need to have a black and white plot, and you cannot use color. At least you can different line styles. It's still difficult to read, but at least it's somehow legible in some way. So you can use a lot of different line styles here. That's what they offer in terms of line styles. And colors, though there's different ways to specify the color. The easiest way is using this one letter abbreviation for blue, green, and so on. So this one gives you some very basic colors. But there are many, many other ways specifying colors. You can also just use RGB tuples. So you can have red, green, blue, between 0 and 255, set those colors. You can also use names, like all the HTML names, like 70 of them, like dark green and light blue and magenta, whatever. There's a lot of different names. You just have to look it up. And if you Google for color names in HTML, or you can use hex numbers, which is the same as RGB, but usually as it's used in HTML pages. All of them can be used as colors, but those ones are the easiest. So if you don't need a lot of fancy colors, this would be the easiest just to go with them. And you can do things. And there's a bunch more of properties you have, like fonts. They have properties. You can rotate fonts, which is nice. So if you want to rotate them somewhere, you can specify sizes, styles, and all kind of things you would like to specify. You can as fonts. So there's a lot of properties you can set, and there's different ways to do this. So just now we just can apply a few of those lines. Just like 1 or 2 minutes. Just try to change the properties of your things. Just like change the transparency, or change the color, or change something else. If you set a text, try to change the font of the text or things like this, if you like, or the size, make text bigger of the labels or something like this. We look at text later, but just you can try maybe your line, change the color of your line. So you have a red line, make it blue or make it yellow or black, just with one of the methods. So as long as you have a reference, you can do this. Everybody get some colors changed? Did it work? Any problems? Good. Let's continue. The next topic is text. So now we had the basics how to make a plot. We will look at different kind of plots later on, but let's look at how text works. So now we would like to add text to our plot. So we still have our plot sitting here, and now I would like to add some text. So you remember we have a scale between 0 and 100, and there are different ways to set text. The first way would be it's called text. So I get a reference to my text with T1, and I just call the function text. So it's the same procedure. Always you call the function, you get a reference. And now I specify where I would like to have my text. And I would like it right in the middle. I say 50, 50. So this depends on the size of a plot. This is a coordinate, so 50, 50 would be right in the middle of this thing. And then you can do something like this. Yeah, you can put some, so sorry for keep it in English. Okay, this would be the text. And see, immediately it appears right there in the text. And this is very important. This text goes with the coordinates. Now I go and this. No, I want to have the panning. That's panning. So I pan this thing. You see, if I pan this one, my text moves along with the data. So I pan this thing and I change the scales here, and the text moves along. That's one type of text. The other type of text is called fig text. So I make another reference, and then it's called fig text for figure text, because this text goes with my subplot. This is the thing where I actually plot the data. And this one goes with my figure, which is this gray thing. And this one I would like to put at point 8. At point 8. So this here the coordinates just go from 0 to 1, and I just write something in there and press enter, and you see now this text appears here on the upper right because I say 0.8, 0.8. So this is 0 here, and 1 here, and 0 here, and 1 there. So the coordinate system always starts down here with a 0, 0. That's like you think as a scientist. Usually if you do GUI programming, the 0 starts up here like in a page. So 0 is on top, and you go down. It's like if you write lines at a page. But here you always start down. The origin is down in the corner, which is important. And now if I do my panning, do this panning, you see, the first text is moving along, and the figure text stays at the same place. That's the difference. Because it's static to the figure, when I can do whatever I want here, it doesn't change and stays at the same place. So that's several other things. And you can also, if you like to, add to your text. You can add tech syntax. Most of you might be familiar with tech or LaTeX, and you can put like Greek letters or stuff inside. So if you want to write an equation, so instead of saying hello, just make a text tree. So make a text tree, and now we put it in place 20, 70, and I make it a raw string here, so I don't have to escape the backslashes. And I put a backslash, and I put the pi, for instance. So that's normal LaTeX syntax, and this should give me, if I do it right, and I have to put it into dollar signs, which is puts tech in math mode, and known as a mathematical expression. And if I do this, you see I put it here. Now you have this pi sitting here. You see, if you look that small, you have to put a bigger one, and put the pi here. But you can always say now pi 3 dot. We just learned how to set properties. See, set font size, and I set it to 20. See, let's say 20. What it's doing with a set font size of 20, and doesn't look like it's going to change anything. Yeah, now it's bigger. You see, you can change the font size and have to redraw it. You can make it even bigger. And now it's bigger, and you have this. So you can write equations. So you should be able to write all kinds of equations in there. So if you like to, you can put your equations. I just saw some guy searching for equations, so you can put equations in there. Okay, this would be those two types of text, and there's yet another one, and this is called the annotation. Sometimes you would like to put, would like to describe a part of your lines more with some comments. You say, okay, at this point, this one is changing from this state to this state, whatever you want to do. And for this, you can use annotations. So for this one, you need to get your axis. So you have lines. So I would like to get my axis, which is just, let's say, line 0. That's it's a line already. So I have my line already. Not lines. So I have my line already, which is my axis. And now I can say, no, sorry, to say get current axis. Get current axis. Have to get a reference first. With get current axis, get a reference to my axis, and now I can annotate this one, and I can have two things. I have the text. I can write something, and then I have a few properties I can set. I can say where I would like to have this text sitting, x, y, or pointing, and I say like x is 70 and y is 20, and now it's putting the text at this place. Draw. Whoops, what's this? Draw. Yeah, see now the text is right here, and this is one thing. And actually the interesting thing is you would like to have an arrow or some kind of thing pointing to your plot. So you can do this using this type of annotation and specify properties of an arrow. So you can use very similar things. So we use our text here. That's where we would like to have our text pointing. So let's say we want to point it to the right, to the middle, to 50, 50. And then we have a second one, which is xy text. So that's where the text is supposed to be. Xy text, which is the coordinates for the text. That would be, let's say we put it in 50, 70, though on top of this. That's the coordinates for the text. And then you can specify an arrow. You say arrow properties, arrow props. And this is just a dictionary. And this dictionary takes, you write a dictionary, so like this. And in this dictionary, you put the properties you want. And I say face color. And now you can specify a color. You want a red or blue, whatever you like. So, and you do this. And if I closed all the parentheses and have everything right, then I should have this one. And if it doesn't show up, you draw. And yeah. And see, now I have this one. You see, I just use the normal property. You can have a lot of properties. You can have very nice badges and stuff like this, but you have an arrow, and I specify this is a place I would like to have a text, and this one is just to pointing to. So you can point to every kind of kink in your lines, whatever you have, and can explain things. So that's very nice. You can make nice types of plots. So obviously with this one you can try to automate things, but it's kind of difficult because you have to put the text somewhere. Yes?
So how does this, you started by showing the text function. And
Yeah.
now we're doing, this seems to be very similar, and I'm wondering what the difference is between this and this annotate.
Yeah, so the question was about the difference between annotate and text. So text is just one plain text. You can specify where you want it. Annotation is very similar. It's actually also a text, but in addition, you can specify this arrow here. You have a text with coordinates, and you can specify where the arrow is going to point to, where this text belongs to. So you can have different kind of connections here with this arrow. So that's something. And this one is also moving along with your plot as a text does, but you can have this arrow, and this belongs together. This one unit, so you don't have to draw this extra. So that's why it's called annotation, though that helps. It's less effort to do this one. Okay. So that's a way to put text. We have another short exercise. It's again just a few minutes on page 11. Please annotate your plot, so your nice sign plot annotated with some. Let's continue with a few more things. So we have text now, see, and we have even Greek letters in there. Let's look at the next topic. The next topics are ticks. So very often you would like to have nice ticks, and this can be problematic for some things, especially if you want to put dates. So if you have dates there and you want to put them on as ticks down there. So let's look how matplotlib is handling those ticks. There are two concepts. You have locators and you have formatters. So the locators decide where you put the ticks, and the formatters decide how they're going to look like. So how the labeling of the ticks is going to look like. And we have something called major ticks and minor ticks. Here's only major ticks. So these are the major ticks, and there are no minor ticks. Usually that would be a minor tick in here, and very often the minor ticks, they don't have any labels. But you can change how those ticks going to look like and how they are placed. So how do you do this? There are a bunch of different kind of locators how to do this. So we just look what kind of locators we have. So see here, we have different kind of locators that have different kind of properties. The easiest one would be the null locator, does nothing. So if you don't want any ticks, it can be, for some plots, can be the right thing, then use an null locator. And then you have different ones, index locator, linear ones, you can use log scales, multiple locator, which we're going to use, so you see how many multiple times you want to put it there. We see it in an example. And autolocator, which is on by default, which is just putting some things dynamically. And that's the first thing, locator, and then we have also we have a locator for dates, which is or for times. So we have this minute locator, the hour locator, day locator, week locator, month locator, year locator, and even a rule for this. And this gives you a lot of power if you have time series. Any kind of time series you want to put it, and you want to show some special kind of dates, and you have a weekday. You always want to show Mondays, then you use a weekday locator and you can show all Mondays, which would be pretty involved if you do it yourself. And stuff like this. You can always do those things, and you should show Mondays or Fridays, whatever you would like to. So let's look at an example how this is going to work. So we have still have our graph sitting there, and we just make those formatters here. So we have two different kind of locators. We have the major locator, and now we decide to have a multiple locator. So it's a class. You see this because it's this camel case kind of thing. So it's a class, and now we have a scale between 0 and, let's look at our graph. We have a scale between 0 and 100, and so far we had a locator of 20. So everything is 20. It's 20. Now we would like to change it. We want to have a multiple locator of 10. Make it final. And mistyped this one. Too many letters. Okay, that's a multiple locator and a major locator, and we have a minor. And this one we make a multiple of 5. So make it pretty dense in this case. Okay, that would be the first thing. And now we say our axis, and this one has an x-axis, and we set major locators. If I press tab, I get this help here, and it tells me what's available. I set the major locator, and I just say major locator. And yeah, and I can do the same thing with a minor. So it actually is the same thing. So we can just reuse this instead of the minor locator. We set the minor locator. So, and we don't see anything, and we use our trick draw. And now see, if you look carefully, now we have this every 10, and here's a small minor. This kind of small kind of tick here, and you see where it's located there. And now we set a formatter also. I say my formatter, I use only a formatter for the major one, and you have different kind of formatters. So let's look at the formatters. The formatters help you to format the text. So you have different formatters, and there's a bunch of them, null locator, fixed, format, function, whatever you would like to do. And we just use here those format string locators. So we can use normal Python sprint, %s, %d stuff to format things. So that's the way we go here. So we say, I would like to have the format string formatter, and now I use just put this %. Let's say I would like to have it 5 digits with 2 decimals, and you have to say a float. So this would be the formatter. And again, if you look at it, it's nothing there yet, so we have to draw things, and we have to set the formatter. So I have to say set major formatter first, and set our formatter we just created, and then nothing there, draw it, and see now it's formatted, and you have this 5 width of 5 and 2 decimals. That's diameter. Actually, the 100 is too big. It doesn't even fit because it's 6 including the dot, but it's not cutting it off as just a normal formatter does. So that's a way you can format things. And the interesting thing is you can also use this for dates. So who's familiar with the datetime module? Okay, so just a few people, just to show you how this works, because it's a very powerful module, the datetime module. The datetime module. So I import this datetime module, which is a part of Python's standard library. And with this datetime module, I can work with dates and times, as it says. And I just make, you see it has a few of those things in here. Make an instance, and I can specify the year, the month, the day, and optionally hours and minutes and seconds and I think microseconds. So very fine-grained. And this one works from the year 1 up to the year 9,999. So for all practical purposes should be enough. And now I have my date. And I could have a second date. For instance, I have a date 2, which is, let's say it's in the future, October 12th, 1:30 in the morning, and I have to do something like this. Now I can say date 2 minus date 1, and it gives me a delta object. So it calculates what the difference is. That's a very nice thing. If you do this yourself, there's a lot of work. It's a very nice thing. It tells me it's 1,014 days and 5,400 seconds difference between these two. And this one takes care of leap years and all kind of things. So that's what it's doing. And I think the only thing is that they don't have the leap second inside, but that's something small glitch. You can live with it. Depends what you're doing. So, and that's very good. And now you can use this datetime objects for access in Python. So you can use just a list of datetime objects and put them in there, and matplotlib can use them. So it's a lot of information in one of the datetime objects. It's very easy to construct because it's in the standard library. And actually, there's a lot of other libraries that use those datetimes. So if you use datetimes, you're on the safe side because a lot of things can use datetimes. And that's actually, because it's our next exercise, you try to use a list of datetimes, and draw it on the axis, and try to format it a little bit. So you can format it in different ways and use datetimes. Okay, please try. Import the datetime module, make a list of datetime objects as your x-axis, and a few dates, make up a few dates for the y-axis, draw a plot, and format it. That's a little bit more challenging than the other very easy exercises you had so far, but I think it's solvable. So a few people solved this thing, so it's a little more involved than the other exercises, but that's the purpose. For some things are pretty easy, but this is a bit more involved. Of course, you have to know a little bit about datetime. So this is an example how to generate a date. Now, you don't know number one. You can just take this and copy it 10 times, and you would have 10 dates. But of course, as a programmer, you want to have a list. So you can do this with list comprehensions, which would be the easiest. So list comprehension says, I would like to have a new list. And in this new list, I want to have a datetime dot datetime object, datetime object, and now I generate it, and I just want to have a few of them. I say 2010. I keep the months as a running variable, and always want to have the first of the month, for instance. It's just a very simple example, and let my I run through a range of, now there's no month 0, so I should better start from 1 and go to 13, which gives me 12. So shouldn't be more, otherwise you have 13 months. And hopefully this works and have some syntax. I've forgotten something for in. So, okay, and now if you look at your dates, it looks something like this. So if you have more, you have a longer list. And now it's very easy to use this in a plot, because we just use this as an x-axis and use some kind of random data, whatever you would like to, for your y-axis, and you can plotted. So it just now I clean up my nice plot in the background, and now I just make a new plot. My plot would be, and I just use my dates, and now I just want to print some random data, and you can use random numbers if you like to, but you can also just make a straight line and make it the same size as my dates. Just dates 1, 2, 3, and this should do it. And see now, it printed this straight line here, and you can see now that's a default formatting of my dates, and it's not very nice because now it's overriding everything. Yeah, and but you could do a few things. You could change the formatting. So because everything is for the everything is for 1 year, so you have always a year with it. So actually you don't need a year. It's redundant information. If you know it's for this 1 year, you could get every year. You could also use a locator, not plot every single tick, but plot only every second tick or every third tick, like once a quarter. This would be fine. So this would be one way to do it. So you could say, now you have this, you have your plot, and now you would like to say set plot, this plot is my lines, I would get my axis, get this line 0, if I'm not mistaken here, and so that's a line. No, I have to get the axis is a get current axis. So, and now the axis has a set major format. I forgot myself. I just did it. Set x-axis. So axis is one. You have to have the x-axis. So x-axis, of course. Set major locator. You set a major locator, and you use multiple locator, and you use a 3. And this should, if everything is closed nicely, should do this, and then you redraw the thing, and that's not what I wanted. So obviously I did something wrong. I just zoom in to see what I did. Ah, yeah. See, there has a 3 that goes by day. So I assume just to go in by months, but it goes by day. So you don't want to use a multiple locator of 3. But you want to have one of 90, for instance. See how this is doing. And now I go back to the original one. You see, and now I just have 3 months here. Unfortunately, I lost the very first one and the last one, but you see, you have only this 3 quarters. This would be one way to do it. You just scale this. But you can also format those things. You can also use this date formatter if you like to. So if you want to get rid of the the year, you just can specify how you would like to format the things, and then you can use a string as you would for date formatting. Yeah, so you can use date formatting. So I say x-axis set major formatter. Major formatter. And now I can just say date formatter, and then I just give it a string close everything. Give it a string. How I would like to set the date, and I think the capitalized month, and then the day. If I'm not mistaken, if it's months or minute. And try this one. And redraw. And no, it's not a month, it's a minute. So the month is lowercase. See, and now it has a very different format. This is just the month and the day. So that's a different format. It looks very different, but for some kind of thing it might be what you want. And you can start formatting the thing. So I dropped the year. So if you like to, you can just do this. We can also just redraw the whole thing. That's usually the easiest. So if you got in some kind of cul-de-sac and you cannot get out, just redraw. That's usually the easiest. Without any locator or anything, just plot this thing. Plot this thing. Yeah, and now you say set major formatter, date formatter, and now you just give it a string, what you would like to, and you just say just want the month. And this should, if I have everything right here, should do it, and we redraw, and now you just have the months. So this might be the best for this one, because if you know it's only for 1 year, and then you have only months, it's even, you can even now it's formatted with a 0. That's also a way to get rid of 0 if you look at the formatting instructions. So that's something, and you can also format for weekdays and stuff like this. So if you try something like this Excel, this can be very, very painful. So it's pretty difficult sometimes to get the dates right, but with matplotlib you can use this powerful thing for the dates. I think it's one big advantage. And as you see, you cannot remember everything. The thing is very big, but that's not the purpose here. If you know the general approach, you can look it up. And there are lots and lots of recipes around, and I use a lot of things, but I also don't remember everything. I forget after a while. You have to look it up what you did for a while. But if you package it in some nice, useful functions, then can you use it later on. And everything's pretty straightforward, and it's very nice. You can experiment, try things out, and once you have it, you write it in a script, write it in a file, in a module, and reuse it later on, and that makes it very, very useful. So you can do pretty fancy things. Okay, so I think it's break time now. We have 20 minutes break. Let's continue with our second part of the tutorial. So now we know how to plot dates. The next thing would become a little bit more organized about all those objects that are around. So we worked with figures so far and plots and things. So let's look a little bit what's around. The first thing we have, this gray thing here is figure. It says figure 1 up here, you might see. So that is a figure, and that is like the widget here that holds everything. And you can work with this figure. So you can get a reference to this figure. Get current figure, I think. Yeah, now you have the figure, and you see this matplotlib figure, and now you can do stuff with this figure. You can work with it, and can change things at this figure. So the figure has the same, this works the same way as all the other objects, has a bunch of set things. You can set a lot of things. You see here, everything here, it's supported. You can set things on this figure. So you can set like the color, that face color, for instance, that face color. And now I don't like this gray. I want to have it green. And I just say face color green. And as always, if you don't see anything, you draw. And now the thing is green. Yeah, so you can access the thing and you can change it. You can also change the size in inches, especially at construction time. We will see this later. You can set the size you would like to have. People can always resize it. That's the default. And you can also set other things. You could set the title earlier on and things like this. So you can do quite a bit with this figure. That's one thing you have in figure, which is the canvas you draw on. And then this one, this white thing, it's called the subplot. Actually, this is subplot 111. Why it's 111? Because if we work with subplots, we always count in rows and columns. So if I do this, if I just clean my figure, and if I say subplot 111, then it's drawing one big subplot. That's a default, what you usually do. But you can also say, I would like have a different subplot. I would like to have a subplot 211. So what does it mean, 211? That means I would like to have two rows, row 1 and row 2, and one column. And this is plot 1 of the thing. So if I say 2, 1, 2, then you have this arrangement. Yeah, so you have two subplots, and they're always, those subplots are nice as soon as you need. Plots are in a nice ordered ways and rectangular ways somehow put on the screen. You can use this subplot kind of thing. So, and this would be the two rows. You can also have, if you clean this again, so instead of saying you want to have 2 rows, you want to have 2 columns. So this would be 1 row, 2 columns. Subplot 1 would look like this. Yeah, that's a way to go. And that would be plot 2 for this. And this you can expand to, obviously, if you do like this, up to 9. If you want more, you can also use just a comma, and you can have more. I just lately did a project that had like 47 plots on the thing, and it's pretty easy to arrange them. So you just clean this thing. You would be the same thing just to put a comma. Yeah, it's doing exactly the same thing here if you use a comma. And now you could also, if you like to use bigger numbers if you like to. So if you want to have 10 rows and 20 columns, you can do something like this. And you see you would have this tiny plot there. So you see 10 rows and 20 plots. So sometimes it can be useful. Now we have a small problem because now we have to go in and scale the sizes of those things. Yeah, but this would be possible. It's just one of them. You can arrange as many plots as you like, and they're all nicely controlled. And if you have so many of those plots, you can also, if you like to, you can also turn off this. If you want to turn off the labels of the axes, because if they all have the same axis, you only might be labeled one of them, and the rest is not labeled because just everything's full of the same labels. And there's a notion of the there's 2 commands here. I've written it down here. It's called first. If it's, you can figure out if it's the first or the last column. So if you have the subplots here, as I showed you, there's this 2. This is last row or is last column. You can figure that out, or is first column. Then you can ask this plot if it's the first or the last, and then you can decide what you would like to do with it, and just have them with the labels. On the others, you can give them a null locator or null formatter, and nothing is drawn, and there's no labels, because it doesn't make sense to have 50 times the same axis. If they are arranged nicely, you might turn it off. Okay, this is a notion. This is a notion of subplots. So subplots help you to arrange everything in a regular kind of things. So this can be useful, but sometimes you don't want it. You don't want it regular. There we have this. So if you don't want regular, you can also use a different approach. And for this approach, yes, we make a very, very simple plot. So keep it simple, make very simple plot. And now you can make another plot with a different kind of size, and that's called the axis. So you say, I would like to have an axis, and this one, now I would like to put it starting at point 2 and point 5 of my figure, so the figure going from 0 to 1, and would like to have it a quarter of the size of the figure. And I can do something like this. So it's the size, so in post dimensions is a quarter of the size of the figure. So this would be my current axis now, and if I do it interactively, it would be set. And did something. Oh, yeah, I have to specify as a list. Sorry, forgotten this one. It has to go into the list with all this. It's just one argument is all the coordinates gathered in the list. So now I have my x. And now this is the current axis, and I can plot on this axis. And I plot my range 10 there also. And if I do this, then I get this plotted, and it looks like this. See, I would like to have this. This is a position I specify. I would like to start at this position in relation to the screen thing, and it should be a quarter of the size of everything, and it's a smaller one. So you can make a plot in plot, and you can arrange plots any way you want. That can be useful. So this is very common. Either you want to show detail here, or you want to show the whole thing there and the detail in the big one. That's very common, for instance. So that's something you do with axis, and you can work with it. Okay, that's something you can do with plots and figures and axes. I think it's very important because you need to know how to arrange the things, and if you want to make things look nice, so subplots can come in very handy, but you still have the flexibility to do whatever you like and place things on this canvas here on the screen in all kinds of ways. Okay, let's do a short exercise on this one. It's on page 8.5. So try to draw different figures with different sizes. So I haven't shown this one. This is for you to figure it out. And add a few subplots to this figure. So the figure is an object like anything else. So you can have access to the figure and then do something with this figure. Problems. Anybody got a problem? Raise your hand, ask. So you can change the size of the figure. We will see this later on. You can make an explicit instance of a figure, but you can also change properties. You see you have this set size inches. And I hope it's just, I don't know if it takes a tuple. So if you see if that size, it's doing size inches. Let's try to make it small. Yeah, see now I changed the figure size. So this figure, the other one didn't change. It has something to do with interactively. If you do it from a script, then the size of the whole window is changing. So sometimes you have some strange. Let's move it back to 5 by 5. You can do something like this. That's like it. Yeah. So you can change this size, but the window itself didn't change for some reason here. If you do this with a constructor, it's going to change. So you can change a few things. You can change the resolution. You can turn off the frame if you like to, so there's nothing around. So if you don't want these menus, you You can turn off all kind of things. And then you have the subplot things you can work with. We looked at it. Okay. So far we only worked with very simple line plots as this one. But you can also, if you like to, have a different kind of plots. So you can have many different kind of plots. I think it's 10 by 7. It's too big. I don't know how big it is. Okay, something like this. Let me figure this out. Okay, there are many different kinds of plots you can do with matplotlib, and these you might have seen already because you downloaded. You just downloaded matplotlib. If you just go and search for matplotlib, then you see the gallery, and this, if you go there, and then you have many different kind of plots. So if you go to gallery, and that's a very good resource. So it takes a long time to load because you have so many plots. And then I think behind each of this plot, you will find the source code for the thing. So they have this. So if you just click on it, one of those things, this is one of the bar plots. Then you see a bigger version, and you see the source code of this thing. And you see some of them, they're not interactive sessions, they're a little bit different, but very similar. See here, you import plot. You import plot explicitly. You import plot explicitly as here matplotlib pyplot, and then this is the one that's implicitly imported if you use -pylab, and then you use this here. You say you get the explicit instance of the figure, and here also you can also supply the size here, and then you work with this figure explicitly. You say add subplot, which we just say when we do plot is doing this add subplot for us and choosing just one subplot. Has a useful defaults, but here you do this explicitly and add those things for you. And see, it's not that big, just it's those few lines, and you get this type of plot, including error bars and all kind of things. So there's lots and lots of different plots up there. So if you look there, there's many different ones. Even something that doesn't really remotely resemble a line plot here, and they're new. I haven't used any of these here, but a bunch of them can be pretty handy. Some very simple ones, and some really sophisticated ones with all kind of things mixed together. And you can also load images. So if you need to show images, you can do this. You can do work with images and lots of things. Okay, let's go to a few of them to see how they look like. So we just keep in our interactive thing here, and I just try to change. That's too big. Maybe 8 times 6. That sounds good. Yeah, 8 times 6. I'm back in my window here. So you look at a few of those ones, and they're simple. Just everything, just what I show you now, it's a one-liner, but they produce kind of decent plots already just with one line. So a bar plot is just you say bar, and then you just provide the data, and you have this data. You want to have the position where you want to put it, 1, 2, and 3. And then you have the size here, and let's keep it as simple. 437, for instance, closing parentheses, and you do a bar plot, and it's plotting something like this. You see the 4, 3, and 7 as a size, and then where you want to put it. And this one, of course, you can do way more. You can give it different color. You can determine how big, how wide the columns are, and all kind of things. That's possible. And there's a lot of variations on this plot. But this is just one-liner, gives you a simple bar plot. So if you need to do some quick and dirty work, you can do this. And it's very easy. You can also, there's a vertical one. So I can use the same thing. Just put a horizontal one, sorry, an H for horizontal, and now it's doing the same horizontally. So you could imagine verifying this one, because there's also one is called the broken bar plot. Let's look at a broken bar plot, which is interesting because this one can be used for some other things. So if we specify a Y range, it says just a tuple 2 to 1, and we have an X ranges, and we specify here now a tuple of lists. So we have a tuple in total, and in there we have 3 lists. It's always a list, and we have the lower and the upper bound. So 0 and 0.5 would be the first entry, and then we have 1 and 1, and the second one would be 4 and 1. Okay, that would be our ranges. And now we just say broken bar horizontally, and we just supply our X ranges and our Y range. And if we do this, we get something. I get something very different. Must have something. It's a very different thing I expected. It's supposed to be a broken. It's a different version. So I'm surprised. I don't know if, because it's supposed to be, the H means horizontal for sure, so at least it should be horizontal for one reason, and then it should be broken as is printed here.
Can you set the Y limit? You have the commands to set the Y limit?
Ah, yeah. So I have forgotten to set, yeah. It's broken. Sorry, I'm mistaken. So this is across. It's horizontal. It's just because it's so thick, and it goes from 2 to 3 here, but they draw too big. That's why. Okay, sorry. It's right. It's just my mistake. It's the next one. I have to go and get the current axis and make it narrow to make it look like yeah. See, and if you can set a lot of things. Set Y limit, and now you want to have it between 0 and 5, and then just draw this thing again, and now that looks much more what you would expect under a broken bar. See, there are also possibilities if you could also colorize those things, and you could make something like a Gantt chart or things like this. So there's a lot of possibilities. In the next one, we will see how we combine different kinds of plots to a new plot. And so if you do some statistics, then a box plot might be nice. So we clean everything. A box plot are very nice things. So we can just put some numbers in here. So this is our range 2 to 10 X coordinates, and a range 1 to 5 maybe. Doesn't matter if it's a range or a range actually for this purposes. And well, seems like it's a new version of NumPy behaving differently here. Okay, this one now is showing me a box plot, and you can see that that's a box plot that's coming up here, and you can see this box plot actually consists. You see, there's just a dictionary, and inside the dictionary you have a bunch of lists. So you see actually the the internals of the thing, how this is set together. It's just the different other primitives combined to a new plot. So, and this is not too difficult to see how this works. So you could even, if you need to come up with a different kind of plot, use this technique to make your own plot. You see, it's just a dictionary, and inside this dictionary you have boxes, caps, flyers, whiskers, medians, all the things. They're all in here. So you have this, the median here, and the percentiles, and the flyers, all those kind of things. It's here. It looks a bit different. This is an updated version. Okay, those box plots can be interesting. Look at a different kind of plot. If you want to get into 2D fields, then contour plots is a way to go. There was a question right in the beginning if there's contour plots, and we have a short example. So if I have x and y, which are the same, just make a very simple contour plot, and that is 1. So 1 is something from NumPy that gives you an array of 1s. Everything is a 1. And now we just randomly go in this array. So that's a NumPy array. So a NumPy array supports this assignment. You can just address x and y. So that would be x and y. And now we can change the value to something else. So if you do this. Ah, yeah. Yeah, sorry. Yeah, 1 has to be a two-dimensional array. Yeah, you're right. Because the x is 10 and yeah, and they changed a little bit. They used to take just 2. Now you have to take a tuple for this. It's a shape. That is the shape of the array. It has to be a tuple. And now you can do this. Sorry, pay attention. And now you just randomly set whatever numbers you want to set to some values, and you should see some effect. So now you have to have this. It looks like this. It's a two-dimensional array. Make it bigger. Two-dimensional array. Everything once, only the ones I set. So this few random, the 5 and the 7 and something here, the 2 here, I changed. And because it's once gives you this array, and I changed it. And now it's very easy to do this contour plot. I just need to supply the data, x, y, and my values. So I just say contour. I think nowadays they have everything in like British spelling and American spelling. So both of them should work, like color with O or with OU. So so if you ever have this problem, it should both work nowadays. And if you do something like this, you end up with a contour plot that looks like this. So that's, you see there's those 3 spots that change something, and that's why I have this contours. And I can also fill it if I like to. Clear current figure. And this easier, I just put an F here, and it's going to fill this thing. So, and this is one, of course, you can also add a legend, a color scale, and all kind of things. So you can choose different color schemes. So that's not so much more work, just a few more lines. Then you can have different color schemes. Usually the red is high and the blue is low. But for some purpose, you want to change it. Yeah?
So in your example, you have fourth parameter to the filled contour. Could you describe the fourth parameter in the V?
Yeah. You're right. I'm not sure. I have to check myself. So if you don't know, you can just always. So of course it's very big, but this should give you help here. So this always happens. You have something you don't know, and then you just press help, and hopefully it comes something out of here, something useful. Yeah, so it's more here, and contour, and that's an N there. See, the V, that's what you're going to fill. Regions between the values supposed to be filled. So I've forgotten what to say. So, and this should give you some useful help. So you can call it, as I just did with 3, you can always call this with a fourth argument, which is a V, and draw contour lines as values specifies in the sequence. So that's how you're going to fill this thing. It gives you the information that is just drawing these contour lines as in this thing. So we can try how this looks like. So there's more information here. So this gives you an overview of all the properties here you have, or everything. So it's pretty decent thing. So you can set a lot of things. And now let's clean our figure again. And we use the X as a V, and see now it's only going using the values between it uses a scale. Now I scaled everything. The values between 0 and 9 are the scales. This is a 7. Used to be dark red. Now it's just orange because the dark red would be the 9. So I give it a scale. This is a color scale. The scale. Now the colors of blue means 0, or no, means 1. Yeah, it means 1 because everything is blue, and then the red would be the 10 or the 9 what I have there. Yeah, so this is the next one gives you what you want, this scale, and you can also add now you can add the color bar. You will see it. So very often you don't if you don't supply anything, it makes it automatic. So it scales things automatically. So the lowest value is blue and the highest value is red, but you can also specify, I would like always between a scale between 0 and 10. And if you get a 12, you get a white area. That doesn't drawing anything. So it's unknown, uncharted land, white. Yeah, so it doesn't know what to do there. So that's whatever you want. Sometimes the automatic is very nice. But if you want to compare things, you don't want automatic everything scaled differently that you can compare. So you want to provides a scale. Like I do quite a few pH plots, well, like chemistry, pH. And then usually you want it between 1 and 14 or something like this. And you always want to have you want to convert it, you want to have the low values red and the high values blue. Otherwise all the chemists they freak out, they say that's not good. You cannot do this. And you just have to convert it to this scale. You can do this, it's not very difficult. So that's what this is good for. Yeah. See, but it's very big and you tend to forget, even if you wrote it yourself. I did something a year ago, 2 years ago, and you forget what it is, and you just have to look it up, what it's good for. But the built-in help usually is good enough to give you a lot of hints to do this. Okay, let's look at the histogram, which can be interesting. Just clear my figure, and let's look random. This random, see, the built-in random here tells you where it comes from. This is not Python's random, but rather NumPy random. You see, so that's a NumPy random, and the NumPy random it's a different thing as the Python random. The Python random gives you one random number. The NumPy random gives you an array of random numbers. So if I use this and I say random rand or normal, I can make a normal distribution here. This normal distribution, normal, and I say I would like to have 1,000 entries. I have 1,000 random numbers. I don't type R now, I would print 1,000 numbers. And I just say hist for histogram and just apply my random numbers. And now it's printing this with a normal distribution. And you see it's kind of a normal distribution. You can also adjust the bins and all the stuff. And but it's supposed to be like a bell-shaped thing with 1,000 getting kind of close to it. So you can do different kind of histograms, and even works now. There used to be a bug somehow. You had some overflow. If you go too far here, this is just wrapped around. But now everything is fine. So the histograms can be a very useful thing to do. But there are a bunch of more things you can do. Everything is very one-liners, just look at a few of them very quickly. So you have this one we just had, contour plots, histograms. You can have the log plots if you like to. You can have a log plot, and you get this log scale here to put things. You can do pie charts if you like to, which is very easy. Just put in the data, and it's throwing out. Looks like a black egg here because I don't have it scaled, and you get a pie chart like this. So everything, just basic plots, is very little work, and you can make them look nicer if you like. You can take this wedge out if you want to put the emphasis on this one. You can just I think it's exploded or something. There's a term for it. You take it out or things like. You can do a lot of things with it with just a few lines. You can do polar plots if you want to. So if you don't want to stay with Cartesian coordinates, you can do polar plots, and then you get something like this. It's very easy. Just polar, and you give it a range of 360 integers here, and then put something like this, and you end up with a spiral like this. So if you need polar plots, it's in there. There's much more in there. There's also, if you want to print maps, they have some basic supports for world maps. So if you want to have every country in the world with a different color for something, you can do this. That would be possible. And as we see, you can also even program in it. So you could, if somebody clicks on the country, you can pop up something. That's not difficult. So you can have event handlers. If somebody is doing some click or some right mouse click or whatever, something is happening, or if something goes over it, you can do something with it. So that's also possible. It's not that difficult to do. You can do arrow plots, for instance. So if you would like to some arrow fields, scatter plots, and a bunch of other things I haven't shown here. If you look in the gallery, you see lots and lots and lots of other things you can do. Date plots, as I showed you, just use dates as a date scale. We used this before. That's the example here, using date plots. Okay, this is just an overview of what you can do. So far, we always use the interactive from this PyLab thing, and it's very nice, but you realize already you always have to do this, like if you forget to get a reference, get current axis, get current figure, those kind of things. This interactive thing is very nice to explore things, try things out, because you have an immediate response. You type one line, and the only thing you might have to type draw from time to time, but you see it already. But if you want to write something bigger, you usually don't want to do this. You rather want to go and write a program that's using the class library in Python. And let's look at it. No, it's not. I don't know why. Seems like it went to the different screen here. I'm looking for my window where I opened the file. And I don't see it. Just to go. I cannot get my editor window back. I had it in the morning without attaching things. You have to open it with a different editor then. Yeah, it's obviously open, but the window is not on the screen, and I cannot see it. There's some artifact here. There's a projector. Just a second. I have to. still not there. Yeah, I have to reopen the whole thing. Okay, so of course I want to show you something in an editor window. Yeah, but we can, if it doesn't work, we can do something like this. That's going to work. Okay, now, is this, doesn't come back? Okay, so, is it big enough? Yeah, so now we finally go to the step, we don't work with interactive prompt anymore, but we rather import things and write a script. And that's something I want to show you, how you do this. So, we import matplotlib, and there are different things in matplotlib. In this case, we use pyplot. So this pyplot gives us pretty much the same API we use all the time interactively, but now we have to write a few more lines because we have to make instances of objects and things like this. Typically, you import it as PLT. And now you see, I set the fixed size to 8 by 5 inches. So this everything is in inches there. And then I make an explicit instance of this figure. So this plot figure is a function, in this case, it gives me a new figure. And I specify the figure size here. It's just this tuple. And then I add this subplot. You see, you already recognize our subplot here. 1, 1, 1 is just one subplot. It's the default you always have. But here you have to explicitly say add subplot, and I get my x axis back there. And then I get a line. See, I say plot range 0, and this gives me back a list of lines, but in this case I care only for the first one. There's only one inside anyway, so I index with 0, so I get my line. And then I go on and say set title, set label, x label, y label, set my grid true, set my marker. That's pretty much the example we did before interactively, but now written in a script. And of course you can also write this in a function to make it look nicer. And then we do something, we save our nice diagram we made, and we save it. Usually it recognizes the extension. So if you supply a PNG, it saves it as a PNG file. If you say you want to have EPS, it saves it EPS and things like this. And of course, here makes sense to specify the resolution. So how fine you want it. You want to have a big with a lot of details. You want a small one with just as a thumbnail somewhere, whatever you would like to do. Yeah. You can do this. So I use this savefig also for other purposes. Sometimes you need to produce, for some reasons, lots and lots of kind of tables as figures or something like this. And this is pretty easy with here you just write a loop and save a lot of things. So that's pretty much the same thing we did before, but now we have this written in the script. Okay, I make it bigger. Okay, and now it's very easy. You just run it. You just type Python, and you run the thing, and it should come up and give you the. Yeah, so it's behind. Here, there's this nice rocket. So now that's the whole plot we just did. So we have a title, we have everything, and it's open, it's waiting here. So it's right here where you say it's show, it's waiting here, but has saved it already because I put the save before. Show is blocking. Now you have to close it, either with Control-C or close it, but it saved it already. So if I close it again, I can see now I have this one here, this file, and there's no command to open it. You have to double click it from somewhere, and if I double click from somewhere, then it should come up. I don't know how they order this one here. I want it by name. Yeah. And now it's saved in this file here. And see, and this is 150 dpi, which is kind of decent enough to use in many places. So nowadays, if you use those ones, and they can be used all over the place. And that's what I usually do. I save those figures, and you can include them in your restructured text documents or stuff like this, and that's pretty useful. So that's a very nice way to store those things, and you can write scripts. And it's exactly everything we did so far you can use in the script, and you can reuse your knowledge for this. Good. How much is time? Not so much time left. Okay, let's go on now. We get a bit more sophisticated. So far we used just very simple plots. Let's go on and make a little bit more sophisticated plots. And now we look in a stacked plot. So I don't know if it's there yet, but when I doesn't do it. Yeah. Okay. When I started doing this, I couldn't find what's called a stacked plot. So a stacked plot is you draw kind of areas, and you want to be stacked on top of each other. Yeah.
I have a question. Is there an enable import that will flood my namespace equivalently to the -pylab on the command line?
I didn't understand the question, Ken.
Well, you've got us the ipython.py -pylab.
Yeah.
And that fills up our namespace with things like plot.
Yeah.
Is there an equivalent import?
No. Actually, in the script, you don't want to do this. This is like something like an import star, which is highly discouraged. And I try not to teach people that's there at all, but they always will see it, but other people do it. Import star is kind of very messy because you override things. You see, we have this random there. You don't know what this random does come from. You have to search for it. So if you write a script, I really encourage you to write the extra line or two and make an explicit import and give the name. It's just a little bit typing, but it helps you a lot if you look at later on where it comes from. And especially somebody else looks at it, it's a very big gain. Make it explicit. So making explicit sometimes means typing one or two more lines, but it's well worth it to do it. So if it's there, I would be hesitant to people to tell that's there, because if they use it, they make your scripts more difficult to read. That's my opinion. So if you want to have explicit, if import NumPy, you import matplotlib, pyplot, and you import whatever you need to get started, and you have explicit reference to it, and you know what's happening. Yeah. Okay. Now I would like to have a stacked plot, and a stacked plot is the same thing when you draw a line and you fill this area underneath the line. I want to have the next line on top of it. So, and not because if you have 4 or 5 lines, everything together is very difficult to read, and you have something that and add the value to the next one. So you have the stacked kind of behavior, and you see this. We very often see this thing, and I couldn't find it actually. Maybe it's there now, but I went on them and programmed my own, and I use this now as an example. So this is a little bit more tidied up here with some documents, and I checked it with Pylint, and it's PEP 8 compliant, everything. So you have some nice example. And so we have this stacked plot here, and I import matplotlib itself, and I import pylab from matplotlib. So there's different things, and I import NumPy explicitly at this stage. I don't know if you're familiar with Pylint. Who used Pylint? Yeah. So Pylint is a static source code analyzer, which is very useful because Python doesn't have a compiler, which is a good thing in one way, but a few things you can catch at compile time or before you execute your program. Otherwise, everything would be execution time. And Pylint is an analyzer that analyzes your source code, and I use it quite a bit. But since it's static, it has a few drawbacks. It cannot recognize some dynamic things like this one is
it doesn't find the members of NumPy which are there but are dynamically created, and it gives you a lot of false positives. And this one, I just turn off this message here. That's what it's good for. So if you don't know PyLint, you don't need to bother, but if you know, you see I turned this message off. And then I use a stack plot. It's a stack plot here which has this different things on it, and I just define my own interface. So I use the primitives that are provided by matplotlib and create my own plot, which is not too difficult. I just want to show you a few things. So I have x, y, and then I have a lot of optional arguments. You see, there's keyword arguments with defaults, axes are none, colors are none, names are none, location is best. So you have some sensible defaults, which is always good. So other people can just call this with two arguments, with x and y, and keep the rest alone. Or if they want, if they feel like, they can override all of them. So that's it's a very Pythonic way to do it. And again, I turned off some message here, and because it says too many arguments, yeah, but it's nice to have it. And now I just create I use x and just convert it to a NumPy array. If it's a NumPy array already, it doesn't matter. It doesn't do anything. If it's just a list, it converts it. If it's not converted to an array, it's something we cannot use anyway. So I convert it to an array, and I do the same thing with my y data. And the axes are the axes here, which is defaults to none. We see what is. If there are no axes, I generate myself. You see, I do get current axes. If I don't provide axes, I get the current ones. And I also have default colors. So if nobody specifies colors, I just use red, blue, green, yellow, magenta, and white. I think it's there. And set the colors, and set the names, and set the location. And if there's no colors, if I don't have set colors, it's nothing set. Somebody provided an empty list. I go through and generate colors here from the length of the data. So because this is just the default ones, but it's more than we need, and I just go through and get how many colors we need, how many Ys. And the thing is, I only have 6 default colors, and somebody provides 10 or 12 or 15 different kind of things under the color, I just repeat the colors again. So I use 6, and then I start from the beginning again. So the same color again. That's just this thing, what this thing is doing. Just taking this apart and using some floor division here. That's not very interesting, but it's repeating the colors. And and then I call self-stacked. So this underscore, it's very common if you want to have a method that's supposed to be called only from inside your class, but you're not so fussy about it. I use 2 underscores, use just 1. It's just a hint to the program, but actually it's supposed to be used inside. And this one is just accumulates the data. So because I want to have it stacked, so I want to have the Ys added to the other one. All the Ys have to be added, so you get a stacked. So if the first Y is 1, and the other one is also 1, then I would say 1 and 1 is 2, so I put it at position 2. So I have it stacked. That's what I'm stacking here, and that's what I'm doing here. I just get the number of lines, which is just the shape, plus 1. Because I need an extra one, I need more lines than I have areas. And then I get my zeros, the number of lines, and the other shape. So then I have my stack thing, and then I fill it. I go through here and fill this one with my data. That's just manipulating the data, the original data, to make it stacked. That's just in preparation. And then I have this draw function. That's actually where this things are in. So I just go through my data. Zip. Who knows what zip is? Who uses zip? Okay, not many people, so I have to show you. Zip is a very nice way to work with multiple sequences or iterables, whatever you want to say. So if I have x, which is range 10, and I have y, which is range 2 to 13 maybe, something like this. So now I can say zip x, y, and they're zipping together a little bit bigger. See, that's 10 is the numbers 0, 1, 2, 3 till 9, and this is the numbers 2 to 12. So I deliberately chose different sizes. And this is zipping it together, and you end up with a list of tuples. This is a 0 from x, this is a 2 from y, this is a 1 from x, the 3 from y, and so on. And once you do this, then you have this structure, and Python has a notion of tuple unpacking and tuple packing. So you can write, just give it a different name to not confuse things. So I can actually loop over x and y at the same time, because this unpacks the thing. So this is a very common thing to do in Python. Yeah, so I have to say y2. I don't know why I say y2, but it doesn't really matter. Just give different names. That's a purpose here. So I flip this together, and now I kind of loop to them together without calculating the indices. There's no increment of index and stuff like this that you always forget or do twice or things like this. So you use zipping for this. That's what I do here. Okay. That's what I do with the zip. I go through, even not only 2 or 3. So I go through all my data and go through the colors. I always have 2 data, so lower and upper. And I have my colors. I want to stack and zip them together. So I do something for all of them. And I say axis fill between. So fill between is some method that comes from matplotlib, from axis. And I can fill between with this color. So between two lines, I can fill this color. Yeah, and then I can set a few more things. I set the color of the line, it's K, which is black, and I set the line width of 0.1. So how thick I want the lines between those colored areas. I do this. That's pretty much it already. And then I just go to the names, because I would like to also write names, and I just have rectangles here. This is an empty list. I go through all my colors, and I append in a rectangle here with this color. I just specify there with this size, so you see this is how it looks like, and then we add a legend with all those rectangles here. So I make small boxes. I can put the color in. Yeah, so I make my own legend and put the names in and the location, which is default. And then I go a little bit deeper here in matplotlib, font manager, font properties, and use the size of 10. So I set the font size 10. So that's one way to do it. So that's the way I found. That's pretty much it. So I make this stacked plot here. And now I also have a get attribute. So this is I would like to kind of supply the same API as always matplotlib is doing, and there override get attribute. So if somebody says my object dot and this doesn't exist, what it writes after the dot, then get attribute will be called. Did anyone use get attribute before? Yeah, so the get attribute is only called if it cannot find the attribute, and then it's doing something. And that's what I do. I go to axis and just return the attribute, try to get it from axis. If it not exist, I raise an error. So I kind of delegate this attribute lookup to axis. So it saves me a lot of work, because everything that axis is doing a lot. It's there, all the attributes are there, and I can just delegate the thing. So it makes it look a bit nicer. Okay, that's it. And now I just make it's just a test here. I just write a test function that fills a few data. So it's just x is 10, and then y is a 5 by 10 array with ones, and I fill just some random data here. They're similar as we did for the contour plot. And now I use my own stack plot. I make a figure here, and then I use stack plot with this data. So Python, I say, okay, I would like to have a subplot 1, 1, and have names A, B, C, D, E. So that's what I chose. And then I can say set title, X label, Y label, draw, show. So this looks exactly as I would just work with a normal plot, but I wrote the thing myself, and it's doing what I want. So I don't have to, every time I want to do something, I do a lot of different things. I pack everything in this class, and then I'm in this case, I have 2 roles. I have the role of a developer of a class, of a library, and then I use my own library, even it's just for me. But you separate it. Next time you need it, you don't have to bother with the details anymore. You just can use it like this. So let's see if we get this to work. So you don't say stacked plot. Stacked plot. It doesn't come. Stacked plot. And back there it is. And looks like this. So that's what I mean with a stacked plot. You see, I gave this thing, and this just everything's just supposed to be 1 and a few random numbers, and it's just, instead of drawing all the lines here, it just adds them on top of each other, and you see this is just stacking up and just percolates through. This is my calculation data, and I draw this, and this is a legend. This is where I made these small rectangles here, and I put the legend here. And you do the exercise, you can try, you can do this not only with, you can do this with 100 colors and it works. It's going to repeat the colors and works everything. So for the most cases, I cannot guarantee it works for everything, but I tested it for a lot of different things and it works. There might be some corner cases that looks ugly or just breaks down. It could be. So, but for most common cases, this works and you have this stacked plot. See, this is an example how you can use it and can generate your own kind of plots. See, this thin line, you don't even see the line is very thin, but there's a black line in here. I think if you just zoom in, you should see this is a black line of 0.1. You see there's a black line in between, but it's always 0.1, so if you can zoom in as much as you want, it won't get bigger, so you won't see it. So there's this stacked plot as it is. Okay, I think that's a pretty interesting example, a little bit much more involved than we did before. But if you look through carefully and slowly, so actually, if you look at the source code, there's always those numbers back here, which are comments, and I have actually written up some narrative here, which explains what it means. So this should be good enough for you to understand what it's all about. So even if you couldn't follow right now and too many new things, you just can read the text and it should come up and you could understand what it means. Okay, we do a short exercise on page 27. Just take the source code. Everybody of you should have the source code. And try to work with the source code and change a few things and see how it behaves, if it's doing what you would like it to do. These are things you just have to change a few data down here. You can just modify this test function and make things bigger, and then you should see a different plot. Did it work for you? Any questions about this? Okay, so we have one last topic, and this is animation. So you can use matplotlib also for kind of animation work. And the first thing I do, I just show you how this works. So just close this. And I just try, and I hope this works. Okay, it does. See, I do animation here. And what I do, it's running over time. And I show you the residual of some calculations. You see, there's a residual starting like the power of 4 and going down to the power of -8, and now it's finished. So the purpose of this is, I think I'm running an external program with subprocess. And this external program is spitting out a lot of numbers on the screen. And I go there and scrape the screen and find the number that I'm interested in. And this is a residual. So you have some kind of solver. So it's a scientific problem. A kind of solver which is solving something numerically, and usually they have a residual. So how far they are away from the solution. And usually it never gets zero. It's getting very small. And as soon as under some certain threshold, you are done. But very often this residual might go up and down, and it's very tedious to watch a big screen full of numbers just to find this one number, and then you see one number, another number, go up and down. And that's what I'm doing. I just take this one number out of many thousand and plot it here online, and you see it animated. So that's the thing. I just close this and take this out of the thing again. And if I start this thing again, you see, and this, then you see now it's animating this thing. And you start there with 10⁻⁴, and there's some randomness inside, and it's going down. And imagine it doesn't go so fast, maybe lasts for several hours, but you always have you know what's going on, and if your calculation is converging or not. So if it might not go down, it might go up, and then you see after a while the trend is up. It's unlikely that you're going to go down again, and then you can stop this thing without sieving through so many screen outputs. So let's look how I did this one. How do I open this here? It's called animation. Okay, so for this one, I need random numbers because I generate the randomness there. And I use matplotlib, and here I explicitly write it for the TK backend. So you need to have TK inter installed to get this thing to run. Because there's a way to write animations independent from the backend, but it's very slow, and I only get it as soon as I click something, it's going to block somehow. But there are different ways to write it, especially for backend. This is an example for TK backend. You can write it also for WX, for GTK, for Qt, but they have to use a little bit different approach. This one is using a callback approach, and I use import pyplot here. Okay, this is just a helper here. This is just a residual. This is kind of what the external program will do. I just simplified it here. This is just mimics what the solver would do. And I just have a start and a limit and a counter, and if I'm done. And then I override call. So I make it make this function work like this class work like a function by overriding call. And I just do a few things here. It's not very interesting. It's just to generate this randomness, random numbers. So as soon as I'm done, I return none. And then I just generate one random number here, multiply it by a value, which is a difference. And then I do a few things. If the counter is 2, I put this diff on the value and set the counter back to 0, and otherwise I set the value to take it off, so go down a bit and add 1. So this has the effect that the general trend is down, the whole thing here, general trend is down, but once at a time I go up a little bit. But I always go up much less than I go down. So that's what it's doing here. But I always, because I do this, I take this diff off, meaning I'm going down and increase the counter, and if the counter is 2, every second time I just put the diff on. So I have 2 negatives and 1 positive with random numbers. So you get this randomness, and all of a sudden it goes down. That's just to mimic this, to make it look a little bit as it would be in reality. And as soon as I'm done, I'm finished here. So that's the whole thing is doing. Okay, that's not interesting for our problem yet, but just to make it realistic. Second thing now, I do a few things. This is a plot that's updated. You see I put all this plot, setting up the plot in here. That's everything we know. We make an instance of this figure. We have our axis, add a subplot. Then we have a counter. Then we have x and a y, which is just a list with one element and a list with one element. So we start out with one element. Of course, we increase this thing and we append things, and this plot gets bigger. And we show the initial graph that's done here. And then this is something specific to TK Inter. We have to get the current figure manager, the window. So we get some little bit internals of this, how the GUI toolkit works. And show the initial graph is just showing the first graph. I set up the graph with semi-log plot, and give it a title and X and Y labels and draw on the canvas. And this explicitly have to draw on the canvas. And then I do an update. And the update is just I increment the counter. And I now append to my X, which is a list with one value. In the beginning, I append my counter, and then my X is growing. So this is getting longer and longer and longer. And my Y is also growing, and then I take my plot and I generate a new plot. So every time step, I generate a new plot. I throw away the old one and generate a new plot and draw it again. That's this updating step. And then I have to start the animation here. So I write a function inside this method. Let's just do the animation. So I get the residual, which is just mimicking this process, getting this number from somewhere. And if this residual is none, it's not none. If it's none, I'm done. That's the signal, I'm done. If it's not done, I do this update thing. So I say graph window after 300 milliseconds here. I give it this animate function. So this is interesting because this is a function, this one. So I hand myself in here, recursively calling myself. So I hand myself into the callback, and this callback will be called by TK Inter itself. So this is this recursiveness. So I hand this function, this will be called, so TK Inter is calling this function, and then I put myself in, so I get this recursiveness going. This recursiveness is something recursive, it's something you have to think about for a while, but this is how it works. And that's just, and I update my graph, I did it update with residual. And once I'm done, I do another step here. So here I start the whole thing. I start this Beginning, I just make an instance of residual, get the instance of the graph, and call this the first time. Put in animate the first time, and then inside itself, it puts in itself. So that's how it works. I'm going to say plot show and start the whole thing. So that's how the animation works. So animation is a little bit more difficult, but it's something you can do, and you can animate. You can vary those things here. You can vary the step, and you can make run it longer. So we have this animation step here, and in the real case, you'd also now this is driven by the animation step. You would also say, okay, just wait a while and just give me only if values change, do some plotting or something like this. Yeah, so that would be modified a little bit, but you get the idea. You have this animation here to show you how it works. Here, somehow I have to close it. Okay, that's done. Get this animation working, and you look at these things. Okay, so you can see you can do quite fancy things, and even have more involved animations where you have balls, kind of circles going, expanding and increasing in terms of kind of value changing over time and changing the color, and have alpha you can look through. So you can do that information, and if the user clicks on it, something happens. So it clicks on it, another window pops up, shows you more information. This is something you can do. And the effort to program this is comparable little as if you would go with a normal GUI toolkit and start from just with a canvas, and just has a canvas, if you coordinates and a few primitives and draw something. It's much more work. You have nice coordinates, and you have a lot of things you can use to do this. So that's, you see the program's not very long, just a few lines, and the other involved animations also like 300 lines. You can write really decent program. Okay. We are through. There's one more exercise I want to give you as a homework here, if you like to do the exercise, and if I will be around, you can ask me questions about it. I will thank you very much for being here. I hope you learned something about matplotlib. Please fill out this survey. They always ask me to do this. You might have taken a tutorial already. You know, this is a URL here. I make it a bit bigger. This is a URL. I just paste it in editor. This would be the URL. It doesn't get bigger. I don't know how to make it bigger here. Yeah, it's in a piece of paper. So that's the URL for the survey. Please fill the survey. And also, I will be around at the conference, so if you like, you can ask me. I also have a talk about HDF5 if you're interested in this one. You're welcome to ask me questions about those things. Thank you very much.